Hello and welcome to my session about what's new in Scylla Operator. My name is Tomáš Nožička. I'm a principal software engineer at ScyllaDB. Before joining that, I used to work for Red Hat on a self-hosted auto-upgrading Kubernetes control plane and in Kubernetes upstream, mostly SIGApps, but nowadays I lead the Scylla Operator team here at ScyllaDB. So I wanted to start briefly by talking about and introducing you to Scylla Operator for those who are new to it. So bear with me for a while and we will just go through the basics very quickly. The operator is a Kubernetes operator for managing and automating tasks related to managing ScyllaDB clusters. What it actually is a set of Kubernetes API extensions and controllers that reconcile the desired state. It is an open source project, so feel free to check out our GitHub. And we also have dedicated docs pages, which should help you out as well. We make about 6 weeks releases for the operator, and we support 2 latest releases, so everyone has time to upgrade. And importantly, it supports N-1 compatibility, so you always have to upgrade the operator in step. So from 1.10 to 1.11 to 1.12, not to miss any migration step. And before we deep dive into the operator, I kind of wanted to show off what's the difference between running this on VM and running the ScyllaDB on Kubernetes, right? So with VMs, you can have a separate virtual machine for each tenant. ScyllaDB runs directly on the host there, and there is just one ScyllaDB running on each VM. It has dedicated resources, it has direct access to kernel, to the other devices like disks, and other processes on the host. When it comes to maintenance or upgrade tasks, everything is left to the administrator and he has to do it manually and follow the documentation. Sometimes that's taking a while. Whereas on Kubernetes, by the nature of that platform, everything is multi-tenant. It all runs in containers. You can run multiple ScyllaDBs on one Kubernetes node. There is a shared pool of resources, which you can control through quality of service classes. The devices are virtualized, but all the management and the upgrade tasks are handled by the operator seamlessly for you. So it can run cleanup when it needs to, it can tell the nodes to join the cluster when you are scaling up and other stuff. It has a declarative API and it reports a status back to you. So talking about the API, here's an example of the major resource that is provided by the Scylla operator, which is called the Scylla cluster. Here, the user just says, I want ScyllaDB version 5.4.0. I want it deployed with manager agent 3.2.5. I want one data center, one rack, 3 members in there, each of them to have 200 gigabytes of storage, 8 CPUs, 200 gigabytes of memory, and that's it, right? He puts it into the API, it saves it, and it says OK. On the other side, there is a controller or operator, whatever we call it, which observes those resources in the API. It calculates what the state of the world is, it compares it to what is the desired state by the user, and it reconciles it. So it takes any action necessary to reach that state no matter what, and it tries over and over again in case it would fail. And it reports status back, right? You can see it reported, I see 3 ready members. Obviously, there is more information in the Scylla cluster resource that wouldn't fit the slide. This is just for illustration. Another thing that's very important when you run the Scylla operator or any stateful application on Kubernetes is how you set up your storage. For the operator, for the Scylla operator, we are primarily oriented on using local storage, so we use the local NVMEs on each node. The reason for that is it gets us the best performance and latency. Admittedly, that makes the setup a bit more complex, but we are trying to gradually set up automation to reduce that complexity. You can set it up with network storage as well, say the one that you get from your cloud provider, but obviously it's going to have worse latency and worse performance, but it's a supported setup. So for the local storage, you essentially get two supported options with the ScyllaDB Operator. One of them is our own local volume provisioner, which is a dynamic Kubernetes CSI plugin. It can create the persistent volumes dynamically, so you don't have to pre-create them. It's directory-based and uses XFS project quota to limit the storage for that persistent volume. And depending on your setup, the throughput is limited with ScyllaDB IR properties. So depending on how you set it up, it may or may not matter for a multi-tenancy concern you may have. The other option is using the upstream SIG storage local static provisioner. As the name says, it's static. So each persistent volume has to be pre-created by the administrator, and there's a fixed count of them. It supports block devices and directories, but it doesn't support quota for those directories. So essentially the only usable use case for that are the block devices where you provision the full node, full disks for ScyllaDB nodes. With that, here's an overview of all the resources that are currently provided by the ScyllaDB Operator. We have already saw the Scylla cluster, which is the main resource that deploys ScyllaDB clusters. There is also a Scylla Operator config that configures the Scylla Operator. It allows you to choose the utility image or possibly log level in the future and options like that. There is also a node config that configures tuning of the nodes and of the Scylla pods as well, and some other node options, and helps you set up a local storage like RAID, mount, file system, and other stuff. And there is also a ScyllaDB monitoring resource which sets up the monitoring stack and connects it to the Scylla clusters. Obviously, that set of APIs can evolve over time. So we do have a generated API reference in our documentation that is updated with every PR, so it's up to date. There are also other ways how you can do it in Kube. You can use kubectl API resources that uses the Kubernetes Discovery API, and it can list the resources that are available in your cluster. Complementary to that, you can use kubectl explain, which tells you the description for a particular field, and you can iterate on that. So depends what you prefer. With that, we can go into some of the features that the operator has. There's just a brief overview of some of the old ones, and we will get to what's new as well here. So first one that almost any operator on Kubernetes has by definition is multi-tenancy, which means you deploy just one Scylla operator in your Kubernetes cluster and can create and manage multiple ScyllaDB clusters within it. It also supports scaling, so if you say start with 3 members and you want to scale your cluster up to say 6, you just edit the field, you say 6 instead of 3, you save the YAML file to the API, and the operator observes it and takes any action necessary to get there. So here it starts creating new nodes, it joins them into the cluster, and it runs cleanup when it needs to. Another one is it supports multiple AZs, which are created by defining recs. So you can say each rec to be placed into a different AZ. On Kubernetes, you can also make more customized or configure it to say use placement groups instead of AZs. So you get all the variability you would get with a standard placement of Kubernetes resources. It supports rolling config changes. What that means is if you change something on the Scylla cluster definition, say you want a different number of CPUs or a different config option, the operator will gradually do a rolling restart of the nodes, making sure a quorum of them stays up. We only take one down and wait for it to come up before proceeding. So unless you use local quorum 1, which is by definition not HA, you should see no disruption. Rolling upgrades is a superset of the rolling config change. It means you are changing a Scylla version in that update. So say you want to update a minor Scylla version, so we edit the image and the version that you supply, and the operator knows you are bumping a Scylla version, so it runs additional procedures in addition to the rolling config change that I described. So say when it rains, it does key space backup, right? It drains the node and does the version upgrade and other stuff as well. Another big feature in the operator is auto-healing. When you are using local storage, your persistent volumes are bound to a particular node. And when that node dies, like the hardware dies or the EC2 takes your machine away, you're essentially left with a persistent volume that is bound to a node that doesn't exist, and normally everything would be stuck. But if you enable this auto-healing in the operator, it can detect that state, it can delete the persistent volume that is stuck and that doesn't have the storage anymore, and it can create a new node and stream the data from the other ones. So with that, we get to the newer features of the Scylla operator, namely configuring AP address source for Scylla clusters, which came in v1.11. This is quite important if you want your Kubernetes cluster to be, your ScyllaDB cluster exposed out of the Kubernetes cluster where it couldn't be exposed before. Before this change, it was always using a cluster IPs that are virtual within a Kubernetes cluster and cannot be reached from either your VPC or somewhere else as well. So with this change, we have also added support for using pod IPs, which is essentially an IP that comes from your VPC. And also for service load balancer ingress, which is a service with type external IP, which is how in Kubernetes you essentially get a load balancer, either with external or an internal IP, depending on how you configure it. So there is a matrix of options that you can now use. This is quite important because ScyllaDB clients discover the ScyllaDB node addresses using a broadcast RPC address configured on Scylla, so there can be only one, and it's broadcasted to clients. So it really matters how you set this up, and you cannot just make network changes. So here's an example of how it was always set up. This one uses the cluster IPs, which is what we have used so far, and with that, your Scylla clusters are accessible for clients only when running in the same Kubernetes cluster, and the same goes for node-to-node communication. As I mentioned, you can configure this independently for clients and nodes if you want to just expose one of them externally. Another option is out of that matrix. I don't have all of them here, but this one shows how you could configure your clients to be external out of that Kubernetes cluster, somewhere within the VPC, or depending on the network config, you could actually peer this somewhere else as well. So here you use pod IPs for publishing the IP address to clients, and it still uses nodes on those service cluster IPs which are internal only. So nodes to nodes can talk only internally, and clients can use the pod IP, which allows them to be outside of that Kubernetes cluster. Another option that you could use is you could expose clients using the service load balancer ingress, which essentially gives you the option to either get them into another internal network or to an external network like internet. It really depends on how you configure those load balancers, but you have the option. And another one that we have here is to show you can actually expose the ScyllaDB nodes as well. So here we can see an example of two Kubernetes clusters, each running an independent ScyllaDB cluster. In each VPC, you could set up one VPC across those if it was supported by a cloud provider, but in some cloud providers, VPCs are limited to a region, so you can VPC peer them. But if you expose everything on pod IPs, you get nodes to be able to talk to the nodes in the other Kubernetes cluster and clients to be anywhere as well. And this becomes important when you want to set up a MultiDC, right? For MultiDC, you need your nodes to be exposed to the other data center, right? And that's also a feature that is available since v1.11. We call it a manual MultiDC support, since you can kind of have to set this up on your own. It's controlled by setting specs and external seeds. And by that field, when you spin up one Kubernetes cluster and one ScyllaDB cluster within it, you just take an IP, one of the nodes in that cluster, and when you are bootstrapping the other one, you use it in the external seeds. In most cases, the Kubernetes cluster represents a region or a data center. So a common setup for MultiDC would look like you would have two Kubernetes clusters. Each of them would run independent Scylla operators, and each of them would run independent Scylla clusters, and you would connect them with the external seeds option. So here is once again the networking setup that you could use for the MultiDC. We have already talked about it. You would set up pod IPs everywhere in the previous slide, and you would now expose the nodes from one data center to the other as well. Another integration that we have in the Scylla operator is integration with ScyllaDB Manager. So there is one global manager deployment in a Kubernetes cluster. And then the Scylla operator runs a small manager agent alongside each ScyllaDB node. It also configures the ScyllaDB manager with access to all of those clusters using that agent. And it also configures repairs and backup tasks that you define on the Scylla cluster custom resource. There's also an integration with ScyllaDB monitoring using a ScyllaDB monitoring custom resource that will manage the deployment and life cycle of everything you need for ScyllaDB monitoring. So at this point, that's namely a Prometheus instance. It configures it with ScyllaDB scraping rules for the metrics, and it sets up a Grafana instance and configures it with the ScyllaDB dashboards. And it also configures the service discovery and authentication between those components. So you get this all just by creating that resource. And here's a brief example of how that resource would look like. You just essentially pick selectors which can select one Scylla cluster or multiple Scylla clusters in the same namespace. Depends on how you have things set up. There is a flexibility in there. And then you configure, like, say, a storage for Prometheus or how you would like the Grafana to be exposed. Another resource that is supported by the Scylla operator is a node config. It is a resource that helps you set up, say, RAID arrays, formatting disk with a file system, mounting devices, and that's kind of everything that you would need to just take the local NVMEs and make something useful from them that you could use for your local volume provisioner. And it also supports device tuning for the nodes and for the Scylla pods. So here's an example of how you would use it for a local disk setup. So here you can see it defines one RAID array of type 0, and it tells it take all the disk that match this regex and make a RAID 0 out of them. Then you define on this RAID array, I want an XFS file system to be created, and I want it mounted to /mnt/persistent volumes, which is where the local volume provisioner would expect it to be. So another feature that we have in the operator is a support for automatic TLS certificate for CQL. So when you create a Scylla cluster, it will automatically create a serving CA, serving certs. It will create a local client CA, and it will create an admin user with credentials. So you get everything that you need for setup of MTLS, like mutual TLS, just from the operator. So you only have to take these out of the secret and configure them for your client, and you are essentially done. And the last feature that I have here for the operator is a massgetter command that's pretty new in the Scylla operator. It helps you collect all the necessary resources that you need to file an issue with the operator. and it drastically reduces the time when we had to ask the users to provide an additional YAML file or a log file or something. So this just gets everything together. You don't have to worry, it reducts all the secrets, so no secret information goes through, and it never uploads any data. It only collects them to a local folder, and you can always review them before you upload them manually on your own. It saves our time and your time as well, so it's now mandatory for reporting issues to the operator. And here's a link how you would run it. It's quite simple, and it saves everyone a lot of time and gives you a better service. So with that, thanks for listening, and I hope you try the Scylla operator if you haven't already, and enjoy the Scylla Summit.